Okay, so this is my video for standard 1.2. It has to do with matrix notation. That shows problem 13. So in the problem, they give us a general quantum system that has three possible measurement outcomes, A1, A2, A3. So therefore we know that any state in the system is a linear combination of those three states. So therefore, by definition of matrix notation, in this basis we represent A1 as 1, 0, 0, A2 as 0, 1, 0, and A3 as 0, 0, 1, just because they're the basis vectors of a three-dimensional system. Okay, so then they give us this general state vector psi written in terms of basis vectors, and they want us to calculate the probabilities of each measurement outcome from this state vector. But before we can do that, we have to normalize the state vector so the probabilities all add up how we like them to. So, and that is they add up 1. So we do that as we normally do by demanding that when we take the inner product of psi with itself, it equals 1, and then we just insert some scaling constant. So when we do that calculation, we find that the modulus of c has to be 1 over 30, so we just choose c to be 1 over 30, so our normalized state vector is right here. Then, therefore, in matrix notation, we can represent the state vector as this, and that should be enough. Just probably dropped it when I was like that. Okay. And then, so now we can calculate the probabilities of A1, A2, and A3 in the state vector. But then it turns out to be really simple because the state vector is represented in terms of the basis A1, A2, and A3. So the probability of finding it in, I called it the ith state, is like obviously the modulus squared of the ith component of the state vector. So, and that's just what I showed right here. And then we know we're in the clear because they all add up 1, and we are good to go. So then, continuing in part B, they give us another state vector, psi, a little more complex one, and they want us to calculate the probabilities of each outcome there. So again, we have to normalize, and we go through the same process, and we find that the modulus of c is 1 over 13, so we just choose c to be 1 over 13, so our new normalized vector is this, and therefore we can represent it in matrix notation as this. And then again, because we've represented it in terms of the basis A1, A2, A3, the probabilities of measuring A1, A2, and A3 are simply just each component of the vector, its modulus squared. And I've shown that right here. And I think that's all there is to it. Yep, nothing else. So that's all I've got for that standard.